Yes, yes, sorry. I will share the screen. Okay, can you see the screen? Okay. Hello, everyone. So we will present our project for the natural language processing homework number 1 or midterm exam. So the goal of our project was to implement both a Boolean and rank information retrieval system. And the system will aim to identify social events through Korea through the data collection of our source. Social event refers to a planned gathering or occasion where people come together to interact, socialize, celebrate, or engage in shared activities. We then chose to focus on cultural and artistic events. So the source of our data source was the New York Times article. Times makes available an API to collect their articles and information about them. So we use the New York Times because it covers a wide spectrum of topics and is international. And also its API is free and easy to use. So by using its API, we can have the information on the left side, so article API. It consists of an abstract text, a snippet text, a lead paragraph, headline, date, URL, and some keywords. To make our program easier to work on this data, we created two subdata classes. The first one is article class, so it's mainly used for display to display the information and later. And the second one, I think the most important, is article content class. This is a utility class that sanitize the information. So like it remove punctuation and it makes all the words in lowercase. And it creates us a big array of words for each article, so it's easier to work on. So with that, with our data organized and classified, we can move forward to data representation. So the first one is to create an inverted index. So to have like a dictionary and have each different one as key, and as value you will have the ID of each document in which this word is contained. And from the inverted index, we can create to represent the words and each and some attribute some value on each document that contains the word. So the first one, the inverted index, we can directly use it for Boolean search. So this is the query we use. We donc not died and art or cultural. We use not died because we found out that if we didn't use it, a lot of article came up, but it was just covering the sad passing of artists and not cultural event or artistical event. For rank search, however, it's not that straightforward, because so first one you need to convert your in a weight matrix, and so each column yes of the matrix represent a vector, So you can see on the left, for example, Anthony and Cleopatra for the name of this is the document, and this is a vector. So we can use them to create a vector space model, and we use the cosine similarity to create a ranked. And after we have the initial ranked with cosine similarity, so the query itself is a vector too. So you can compare the query and each document as vectored with cosine similarity. So having the first cosine similarity, we used a time, what we call a time discount. So we retrieve the date of each article, each date which is public. It is from today, for example, the better score it will have. So this is the result of our rank stage. We just search cultural art location, and I will talk about the result just after that. So we having the document that our IR system retrieve, we can then create a graph, because each document is marked if by yourself if it's relevant or not. That's why we needed the article class on the first one. So it is ranked from 0 to 5, 0 being the least relevant to our subject, and 5 being the most. With our Boolean search, we retrieve some very good documents, and some not so good. But having this representation on a graph, on a statistic like that, we can easily identify when social events are happening. So maybe, but for example, in this example, from the period of November and December, we have quite a lot of social events. So having a graph like that, maybe we can have some statistics, some prediction on social events happening in Korea, or at least when the New York Times cover them. And so this rank search, as you can see, is not as good as our Boolean search, but we still have some good. We still have some. It still retrieves some relevant document. So the next step is to evaluate our information retrieval systems. So the first one for Boolean search, we use precision and recall. So as you can see, it has quite good precision, but to improve this, I think we can improve the code by itself. But I think the main reason to improve the precision of our Boolean system is the query itself, because Boolean search, like I said, it's Boolean, it's 0 or not. So the system is quite strict by itself. And for the evaluation, but we use also R precision and average precision and mean average precision. So to have the mean average precision, we used three more queries that are very similar to the one that we showed you. And we used also normalized discounted cumulative gain. As you can see, so the evaluation is not very good. The precision is less than desirable, and also the normalized discounted cumulative gain is quite surprising, like reverse. Like for some reason, the system picks less relevant document and put them first. But maybe I think it's linked to the time discount. So the matrix not being very precise. Like it still has a lot of words that is not very relevant. But overall, it can still retrieve some document with relevance. So this is the end of our presentation, and thank you for your attention. I'm sorry, I don't think we had the time to do that. So I am not sure. From memory, I think it's not very a big difference.
I would share the screen. Okay. Can anybody see the present? Okay, it looks good. Yeah.
Yes, so welcome to our little presentation about our first project, ER evaluation and social event detection, a comparative evaluation of a vector space and Boolean model for Korean election and information retrieval. Yes, so as first of all, our table of contents. First, we talk about the data collection, then the implementation of our ER systems, in specific the Boolean and the vector space model, then about the exposing the functions, and last but not least, our evaluation. Yes.
Okay, I would start with the data collection. We focused on a 1 month interval from 12th March to 12th April, and we used 3 APIs for that. Like pretty easy to use, but we had limitations because we didn't get the full content, and we used additional crawling techniques with Selenium and got banned for that because of bot behavior. And you also didn't get that good results because most of the articles are behind the paywall, so we didn't use that. Then we tried the Guardian API and also additional crawling with Beautiful Soup, and this looked pretty good, but we didn't got that much results, so we used another API, Genius. This was paid, but we used a trial version and we got pretty good results with that. This is basically like these are articles from Google News. Yeah, and in total we got 723 other CSV file and CSV files, and because we have to use this data for further analysis. And for our project, then we implemented a database logic to like insert all the CSV rows into a database. This is our post data table, and yeah, that's it for the data.
Okay, then we start with the implementation of the IR system. In the beginning, if we summed up all the words of the different documents, we got a total of 440,000 words, which was quite a big number. And I think that summarizes why we need pre-processing. Yeah, the slides shows the different pre-processing methods we used and the vocabulary before, after, and the percentage change. So in the beginning, we just removed all special characters like implemented an isEnglish function, where we set a custom-made threshold of 70%, and only documents passed, or we only considered further documents which had an English, or where the words have in the documents were at least 70% English. Then we removed also all non-English words because our IR system is in English and the user should search for documents in English. We removed also all stock words. We removed we used lemmatization and removed all words that occur only once, because we thought that they are too special. Because if a word only occurs once in over 700 documents, it's too specific and not generally used in the topic about election, and the user should not use it. And in the end, we also removed all duplicate words with sets. And as you can see, the most impactful words, the stop words and the duplicate words. So in total, we reduced our vocabulary to about 6,800 words, which is about 1.5% of the original size. Then we start with the Boolean model. For the implementation, we followed mainly the strict. We set up an inverted index and a term frequency map. For that, we just use dictionaries in Python with the term as a key. And the frequency map, we just used an integer as a value and summed it up. And for the inverted index, we used as a value in a linked list. And for the implementation of the Boolean model, we followed a set logic approach, where we have in the beginning a set of all the document IDs, and then we retrieve another set of the documents based on the words, for example, Korea. Then we retrieve the document IDs to set operations like a union, not, or the intersection based on the different operators like and or not. And in the end of the Boolean model, after we retrieve all the document IDs that after we get all the document IDs for the special query, the API also sorts the document based on the host state.
Yes, so then we continue with the vector space model. So first of all, here you see a picture how the basic vector space model is working. I think we talked about it enough also in the script and maybe in the next presentation. So we are going to just giving a quick recap. Yes, that's the implementation. First, we create a term document matrix. Then we calculate the TF-IDF values. Then we create the TF-IDF vectors for each document. Then we create a query vector. After this, we calculate the causal similarity between the query and the document. Then we rank their documents based. Yes. So vector space model enhancement, we use singular value decomposition for it. Here's a quick picture how it works. I think we talked about it in the last class. So yeah, everybody should be familiar with it. So why did we use SVD or single value decomposition? Because we had the problem of the curse of dimensionality, which means even after the preprocessing, which was pretty effective, as Patrick showed before, we still had a matrix of over 6,500 dimensions. So we needed to reduce them. And SVD is perfect for it because it's a mathematical tool which can be used to reduce dimensionality while still keeping the most important informations. Yes. Then we did another enhancement of our vector space model, the date coefficients. Yes, so we defined our topic. Our topic is the social event detection. So it's always connected to a specific time frame. This means we have defined our user need as he needs rather newer documents than just documents k, which is a real valued non-zero element number. Which is proportional to the publishing date. So we multiplied our causal similarity with it to focus on newer articles. Yes. Then we had problems during the implementation. The mapping of the document and terms, it was a recurring problem because it was always hard with so many dimensionalities to keep track of the words to which document they match and everything. Yes. And of course the time complexity, because we had like a big data set, and when you're working with big data sets, especially with for loops, for example, you have to keep in mind that the time complexity is high and it takes some time to walk through the loop. Yes, now we continue.
Yeah, now I'm talking about exposing the functions, because it was an open project. We did some additional stuff, and first we created with 2 HTTP endpoints, and so you can now use these 2 endpoints in any application. And on top of that, we built a user interface with Next.js and Next UI. You can see that here. This is the UI for the vector space model. You can just search, like you can just type anything you want in there and get results, and also have a link there. And that's the user interface for the Boolean model. You can add as many rows as you want and have the operators and or not. Yeah, and we also deployed it on Azure, so everybody can access our systems, the UI and the API. Yeah. Now the important part, the evaluation. We used 4 queries for that. The first one is political corruption scandals. The second one is election 2024 turnout. And the third one is Democratic Party. And the fourth is Women Rights People Power Party. And we used different query options for the Boolean model because like how the logic is working. And we try to make it as fair as possible. And then we retrieved all the documents and did a time plot in a daily interval. And the election day was on the 10th April. So you can see in like pretty much every chart spike there. And yeah. And for the recall, precision, and F1 score, we had to build a ground truth dataset, and we had to go through like all the rows and articles. The query is like you would expect the article there or not, and then we could calculate the recall precision and F1. You can see like just a quick picture. I will talk in detail about it. Yeah, first the recall, and you can see the vector space model has a higher recall in average than the Boolean model. And when it comes to precision, the Boolean model has a higher average precision than the vector space model. And when it comes to F1 is like a combination of recall and precision and the ground truth dataset. And you can see like a slightly increase in the Boolean model. And this is indicating overall better performance, but it's just, yeah. So in conclusion, vector space model has higher recall but lower precision, and Boolean model higher precision but lower recall. But this is as expected. Yeah. Thanks for listening. Yeah, that was our presentation. Cool.
Yes, by the new ranking variable k, we mean that we use the because we defined our user need that he rather needs newer articles. So we had somehow to implement it because the cousin similarity does not doesn't take into account that like the articles are from a different time frame or different time slot. So we implement a new ranking variable in order to like multiply our cousin similarity by a date coefficient, and that's the variable k basically. Yes, I hope this answered your question. If not, we can go into detail with this.
Okay, hi everyone. Just let me share my screen.
Okay, sorry. I have to start another time Zoom. Okay, is that okay for you? Okay. So today we will talk about natural language processing and information retrieval system about Korea. Oh, sorry, I don't see the chat. Okay. About Korea event detection. First, we'll talk about the team after our approach, data collection and challenges, IR system and evaluation, finding. Our team is composed by Mathieu Robert, me, Kylian Paulin, and Daniel Chalier. Our approach, we need to gather information from various platforms, such as social media. So for this, we use the news API. First, we choose to use Le Monde, but it was not announced in terms of documents. So we switch, and we need after to change our system because we will share after that. But our IR system was tokenizing elements in French, so we change it for English. Next, we must develop an information retrieval model that incorporates elements of both the Boolean and vector space model. And lastly, we will assess the article we find focusing on the recall precision and time relevance. About the project, in a methodology, scrapping, and news API for accessing and integrating additional news data from various sources. We choose to collect data from February 14th to April to yesterday, focusing on time when strike was most actively discussed. And for our source, we keep Le Monde as a source as well, but we used also the New York Times and Business Insiders, which provide diverse perspective and extensive coverage of the events. That's how our data collection is working. So we use News API and Scrapper for data collection and scrapped all the article directly from the source website. So even if we use the News API, we need to scrap it because News API send us articles by HTML code. So we need to use Beautiful Soup to parse it. So it the same methodology to get this information. And first time when we only use the Scrapper and Le Monde, we have like 12 documents. And now with News API, we collected total documents of 432. So it's almost good. Our system is really simple. Our users send a query to fetch different information from the system, and after the request, we request news from News API. It will get all the data and return us a message on success or failure with the contents of each document. For our IR system implementation, we used two models, Boolean models and vector space model. For the techniques used, we use time frequency and similarity. After that, to detect the document by relevance. Our user input a query in each situation with parameters. So our program got dash dash boolean or dash dash vector to change our type of query. And after that, the IR system read and preprocess files. So it tokenizes each word in each document to have some similarity between documents. with a regular expression. After we took the text, we create an inverted index to get all the data that we need to analyze the system. And after we try posting for temps to display the results to the user. For findings and analysis. Parameter here, dash dash vector and our query, and dash dash boolean and our query. So as we see, we got a problem with precision and recall. So we got a problem on boolean model, so we need to implement it. But as we see here, for crawling data, we used a different format for timer events. We put the format in the file name, so we can easily see the timer events here. For vector space model, data strike query, there is three first document that has different as boolean. Like here we can see that on the 1st April it's the first one, and after the second one is 21 March. And it was a challenge for us because when we implement the timer events, some articles are not correct in our results due to the weights that we put on time, and it was really difficult for us to handle this. And as we see in the border, we choose to test something like doctor not party to change from basic queries with end. And it was more accuracy in term of document, but there is no relevance. So there is here a difference, and the second one was more recent than the first one. In precision and recall here, we got for the vector space model 0.5 and recall 1. In conclusion, this all the class and all what we seen before, and it was a really good project to learn different things about NLP. Thanks, everyone. Yeah. As I said, we consider the timer events. So it was like when we put the time in the document, simply as I said. Oh, okay. So I just finished. Simply as I said, we got a problem with that because first we put too lot of weight in timer events. So it was difficult. The result was not good, but after some tests, we got it.
So we will present the detection of social events in Korea. So I let Timo talk about the topic.
It appears that Timo isn't here, so I'll just take over the topic right now. So in general, and so the strikes mainly included the medical strikes. So when we did our API search, If we go to the next slide, we'll see how we collected our data. Basically, yeah, we used a news API, and we had a limitation for the number of requests. But we were able to get around 500 articles, which included the title, description, date, and source. And we used Python in order to conduct the project. And we put it all in a CSV file since we were supposed to keep this data for later steps of the project. And we can go to the next slide. Yeah, so now we're going to talk about how we implemented the Boolean model. We've had multiple limitations in the data collection, so this affected how we've implemented both the Boolean model and the vector model. The search on the title instead of the content, since the content was truncated and a lot of them it was empty. And we did try to scrape using Beautiful Soup. However, it was very, very slow, and we had very, very limited time to successfully scrape over the around 500 articles we got. So when we tokenized the article using NLTK tokenize, and this would enable us to search for the words properly when we're inserting our query. And we implemented our posting lists using a dictionary where our tokenized words are the keys and its posting list is the value. And then to implement the Boolean model properly, we made two stacks, one for the operands and one for the operators. And simply when we hit the Boolean, basically if we hit the AND Boolean operation, we take the intersection of the operands in the stack, the intersection of the posting lists, I mean. And if we hit the OR operation, we would take the union of the operands, and we would take the difference of the stack. And then later on, we would return this to the user with the list, with the results of their query. And then we will talk about the vector.
So now I'll talk about the vector space model. So it is divided in two main parts. So first, the data pre-processing. So first, we used the NLTK library to define the stop words in English language because we used articles in English. And for that, we also created so to obtain the roots of the words to facilitate the model. And then we remove the stop words. And after, of course, we clean the data and the query. So after we constructed the vector space model, so thanks to the scale-learn library, so we created two TF-IDF vectorizer. Then we fitted them to the preprocessed data and the query to obtain term-token weight matrix and the query vector. Of course, we computed the cosine similarity between the query to obtain documents, and we ranked them. So thanks to the cosine similarity to obtain the most relevant documents. So we could rank, we could choose the rank. So we could choose 10 documents, for example, to our query. So of course, like we saw in classes, the main challenges were context and polysemy because words are processed separately. And of course, since our topic was strikes in Korea, we fetched some articles about strikes in North Korea. It's the same word, but not the strikes. The walkout idea we found, we were searching for. And I tried to improve this model. So because our data, for our data, we used at first only the title, because the description was truncated. I tried to use the vector space model for a title and description. Paper 3K, a library in Python, to fetch all the description, download all the web pages and parse it, but it was way much longer. So for the evaluation part, we stick with the VSM model, where only the title is fetched. So I think Timo.
Can you hear me right now? Or
Oh
no?
yeah. Okay, good.
Okay, great. Okay. So yeah, the original topic, it has been changed because for the original topic, we couldn't fetch any data, so it wasn't like a relevant topic. Okay, so now we'll explain the evaluation. So first we had to calculate the recall for both the Boolean and the vector space model. For the Boolean model, we got like six. Sorry, the recall it was very low. But for the vector space, we got more. We got 16 out of 22. So the vector space model was better at recall. For the precision, the Boolean model, we got 7 documents, out of which 6 were relevant. So the precision was actually pretty good. But the vector space was a bit better because we got 16 out of 17 documents which were relevant. So overall, the vector space was better. We can see this by calculating the F-score, which takes like the average of both. And as you can see in the table, the F-score for the vector space was better. So overall, for recall and precision, the vector space was higher. We also calculated the temporal relevance for the documents that we got by looking at the times at which documents were posted. And if we took 1 week as temporal relevance, it's actually better because it got 2 documents which were relevant, and the vectors 2 out of 7, and the vector space only got 4 out of 17. So it was a bit lower than the Boolean model, but the Boolean model it's not really selecting those news articles because of temporal relevance. So it's more like luck that the Boolean model got this better. So if you had to define one winner, then I would say that our vector space model was better. But of course, for like any search engine, our vector space wasn't up to the norm. But for this experiment, the vector space was better. For the trend in the news, we created the table on the right to see how many news articles every 5 days were posted. And you can see that in the first 5 days, it was very relevant, but actually the topic has declined in relevance over the last month. So it became less and less relevant. This could be because of like the elections in Korea that were going on. So maybe the other news was pushed back, like about the strikes. Or it could be because the doctors have been getting their license suspended because they were protesting. So maybe those could be the causes for the news being less relevant now. But yeah, that's basically our evaluation for the topic. So thank you all for listening to our presentation.
Okay. Sorry, I just have to, I'm using a Mac and I just Zoom to share my screen. So I just quit the meeting and I'm going back.
Do you hear me? Can you see my screen? Yes, okay. Sorry, I could not read and okay. So hello everyone, we are the team 8 and I will explain about our homework. So the topic we choose is we saw a social event as something where the people can also talk, have social interaction and things like that. So we decided to talk about the events and the dates of K-pop concerts. We searched from documents that were written between the dates of the 1st and the 16th of April, and we searched in French online newspaper, Le Figaro, Le Monde, and 20 Minutes. So our development and process steps, we have 3 steps for our developments. The first step was the document retrieval. The second step was the information retrieval evaluation of our systems. For the document retrieval, we used the Google Custom Search Engine API. This allows us to create like an API that will especially get newspaper from the 3 websites that we wanted. So it was pretty useful because if one day we want to change our topic, we can use the same system and we do not have to change our entire crawler or API. Once we have a lot of document retrieved with that, we just implemented in Python a basic Boolean model. We not explain the Boolean implementation, but our query in our case that was the K-pop and the concert or the date. It was the query that then it's the same. We implemented the vectorial model. So we did our vectorial calcul based on the different documents contents, and we could have a ranking with that. With the end of the implementation of these 2 systems, so we have a ranking and list for both the Boolean and the vectorial systems, but we need to check now if these documents are interesting or not, and if our system works well. So for that, we evaluate using the recall, the precision, and the time reference. But one big problem is that we need to like check by hand every document to see if they are revenants or not. And only once we have done that, we can calculate the recall and the precision. We do not want it to do that because the topics, we need to do it again. And also it's complicated to check a large number of documents. So to manage this problem, we use the OpenAI API with ChatGPT 4. And we ask GPT to select, like we send it the content of our different news to GPT to have like a third party information retrieval system that could tell us if this is suitable or not with our search. With that, we can have like a third list of selected documents by GPT, and we can use this third list to calculate the recall and precision. For the time reference, it is simply based on the difference of time from today. And if like we have a third score for that, and we will reduce the score if it was written a long. This is our different results. We are pretty happy with the results. We can see with that the vectorial system is better. The recall for the Boolean system is 0.895 because it does not found every document that were noted as relevant from our third-party system. but the vector IR system does. So that's why we have for the bed document a recall of 1. About the precision, both those two systems does not selected invalid documents parts. So it was very, very good. But the main difference at the end was the temporal equivalence. Because the vectoral system selected more accurate documents, you also have documents that were written not that long ago. So it has a better score, and that's why our vectoral system is the best here. Is like we could, with that system, detect 3 concerts and the dates from the newspapers. But one thing that I need to say is that the dates of the concerts may not be between the 1st and the 16th of April, and it is normal. It is because the temporal reference is based on the date of the written newspaper and not the date inside. So maybe in the future we can add a 4th score of reference based on the dates that we can find inside the documents. Thank you.
Yes, so the presentation, please.
Okay, you can.
Can you all see the presentation? Okay, I think it's yes. So, hello everyone. Today we are going to introduce you with Bastien, social event detection from retrieval courses. So first, let's talk about the subject that we choose. It's about conflict with North Korea. We didn't mean to offend anyone, if so. Mine. So if you're offended, don't be. So to continue on the project, we have to define what is a social event. So a social event is an event that comes from a short period of time, like a month, and which result from different and multiple documents related on this event. So if we can detect a multiple related documents on an event, it means that we detect social events. So to work on this project, we use 2 different sources, BFM TV and France Info, which are newspaper and news TV, very famous in France. And we got the so that was
So for collecting data, we used Python, and we scrapped using Beautiful Soup. So we just send a request to these 2 sites, get article about South Korea, and after we collect data like article, title, dates, and we put it in a database named Supabase to get online database that we can use together, even if we are not in the same place. And it's better because we don't have to get the data every time we want to do something.
Can you get back to the previous?
Oh, excuse me.
Yeah, don't worry, it's okay. So we got the 166 documents, but first we did have much more documents than that. So in order to fill on our subject, we use a database that stock like around 3,000 words related to a conflict with North Korea, so bomb, Kim Jong-un, or something like that. And if the words match one words in the one of this document that we retrieve first, we keep it. So the final result was 166, but we got much more document than that from the BFM TV and France Info TV. Yeah, you can go to IRS. So to work on this project, we implement two IR systems. So I will talk about Boolean model, and then Bastien will talk about vector model. So how it works. Boolean model works by treating documents with we have different words that we want to find or not. So we can use a different condition with that, or and not. And for example, as an example, sorry, related to our subject, I can use the query of Kim Jong-un, myself, Kim Jong-un or myself, North Korea, and kills, and not Putin, for example. And for each of the queries, the condition that I made, if I got the 1, it means that we reach the condition. If we got the 0, it means that we didn't match on the documents. So after that, if the different condition that we made, it means that the document is relevant. So about vector model, I will let Bastien talk about.
Okay, so for vectorial model, we used the article, and we create a sentence that describe our topics, and after with this sentence we will attribute an importance about each word. So the article, after we will analyze it, and we can see which one are more similar with our sentence. For this, we used sklearn and some function about them, and we kept the date of the article to class them after by date and create temporal relevance. And so for temporal relevance, for example, we can see we have on this date. So in November of 2022, there is like 12 articles made at the same time. So that means that there is, we think with our definition, a social event. And I will let Nathan talk about Boolean model if you want.
Yeah. So to me, we cannot see well the picture. Sorry about that, but we detect a social event on the January 24, and because we reach like 11 documents relevant about our subject, about precision and recall. As a result, we didn't reach as we expected. The percentage was under 50%, so it's considered as or the test or the documents was not relevant or something. However, we did learn a lot about how Boolean and vector model works and how it was programmed too. Thank you for listening. I think, how did you make a ground truth? Ah, okay. It's not for me.
Okay. Can you see the screen? Okay. So let me begin our presentations. Our topic is the Fubao, which is the panda exported from China. The reason why we select this topic is really hot in Korea. It was really popular and lots of articles, photos, and even merchandise products were everywhere. So Fubao is now returned to China, so we cannot see it again. So there are so many people who are really want to see this panda again. And so next I'll talk about how we collect the data sources from here. So we use the ABC, Google, BBC, and the New York Times as the data source was called by calling the API, and the New York Times the API by calling the JSON. To explain the news API real quick, you can query the articles from various news sources from here. And also we can filter the articles related to Korea using the appropriate queries like Korea Panda or Fubao. And it supports the filtering, so we can query only for our interest. The news API, we can obtain the various articles from the New York Times or not even mention like really various publishing companies. And also the New York Times API also supports for the filtering. And moving on to the IR system, we have the Boolean model first. We can read data from the CSV file, which is pre-processed, like converting from the JSON file to CSV file by concatenating also the timestamp. And by filtering the data by search the terms that we are given for based on our interest, and we can create the document word metrics and apply logic operation like and not by to query only for the interest, and we aggregate data by the date, and finally the visualize number of items by dates in the graph. And next, it is the vector space model. We implemented the VSM for the document similarity measurement. And to do so, we leveraged the model from the scikit-learn. So we could tokenize and vectorize the data into the vector TF-IDF vector using this by leveraging this model. And string and its documents. And next, we sorted the documents by similarity and extract data and calculate the frequency of the occurrence, and also visualize the number of the item by dates in the graph. So this is a result of our execution of our program. So first, we run the program by giving the keyword Fubao. The left side is the Boolean models graph, and the right-hand side is the vector space models graph. There's and the x there's a date on the data, and the right is the coherence of how many articles are popped out on the given each day. And we have the GUI, which is created by the Python TK. Right upper box, then we can see what the query keyword here. And this is the keyword for the panda. As similar, we can see this left-hand side graph and then right-hand side graph by calculating the similarity and the result of our model. Also, we can see the GUI results from here. And finally, we have the China keyword. So we can see this graph similar like just before. Okay, so this is our result. So we can get the recall and the previous precision value. We counted the article in our pre-processed the CSV file by dividing get the recall from here. And to get the precision value, we divide the true positive by true positive plus false positive. So we can calculate all the recall and precision values as the based on the Boolean model and the vector space model by giving the term panda fubao China. So this is the overall result. So on the Boolean model, we can get the 0.6 as the average, like recall, and 1.0 for the average precision. And for the vector space model, we can get the 0.8 and 0.9 for the average. And to concern the temporal relevance, there were several things to do, like storing the data by showing latest item first and aggregating and visualizing the result by date. So we could allow the use of the social trends as the time flows. Yeah, so we hope to show some demos here, but I think there's no really plenty of time to do so. And let me show just a quick the graph that we can query from here. Yeah, when we query by Fubao and China Panda and China, we can obtain the graph by calculating based on our models. Yes, so that's all for the presentation. How many news articles has been? Yeah, we got for 300 news articles from News API and the Google at the end for the New York Times. Yes, is there any other questions? Okay, thank you so much.
So for our presentation, we choose for subject, for topic, the social movement and advocacy campaign in Korea. Our method to gather all information was to scrap a website and using their API. For website, we choose to scrap the Guardian journal. And Milan and me, Tommy. And our mission was to gather all articles related to our topics. So South Korea social event movement and advocacy campaign. To accomplish this, we choose to scrap data in Python and get some data with API. To scrap, we use Selenium. And I'll let you go to continue.
Yeah, so do you hear me normally?
Yes, yes.
So to get the data, first we use, so like Tommy said, the Gradient free API. We use some query params only get article related to South Korea, and the most important one was the time frame. So we only want to got article from that was post during this time frame. So it was between the 27th of March and the 18th of April. So after that, we were able to uh, retrieve our first data, but we got a problem because the API only got us the title and a link to the article. So to fix that, we use Selenium uh, to got the content of the article. So with this, we could use the different model. So for the vectorial model, we do some text processing with tokenization and lower casing of all the content of each article. After that, we use the TF EDF vectorization technique to so the content of each article underwent a transformation process. So we assign some weights to a term based on their frequency in the article. And so we can use after that a cosine similarity calculation to do a comparison between the vectorial representation of the query and each article. And with that, we could we generate with the title of the article, the content of the article, and a similarity score. And we put also the query that we use because we use a new query inside the model that was South Korea protest strike rights activism. So that was the query. And we use that to have a more precise article, a more precise filter. And for the Boolean model, we also do some text processing and some query processing. And after that, we did a term presence check. So the Boolean model went through each article and he searched for the find them in the article. It was relevant, and if he didn't find them, it was classed as non-relevant. So for the result, we only output the article in a file CSV that were marked as relevant. And if we need to compare the vectorial model to the Boolean model, we can say that the vectorial model is a little bit better because the problem with the Boolean model is like uh, when we get an article, it's either good or either bad. You don't have in between. So with the vectorial model, you with a score based on the relevancy of the article, you can get a lot more of good. If we want better results with what we got, it will be really nice to get a lot more of article and to use different API because we only use the gradient. And we can show you like on the data is some output of the Boolean model at the left. Uh, Tommy, oh gosh. Okay, thank you.
Hi, can you hear me? Okay, Tommy, can you mute yourself, please?
Thanks. Okay, we'll start sharing the screen. So, hi everyone, we'll present you today what we did on the project of detecting social events in South Korea, what subject we chose, our works on recovering the data, computing the models, and we'll do a presentation of our results. On this subject of detecting social events in South Korea, we chose to focus on exhibition for several reasons, which align with the main subject. First, exhibitions, including art, trade, and cultural show, are significant social events that often reflect current trends. By monitoring these events, we can gain insight into what is currently important or popular in South Korea, making them a valuable focus area. Then, focusing on exhibition is particularly useful because these events are generally planned and advertised in advance, providing structured data such as dates, locations, and themes sometimes. This information can be systematically collected and analyzed to predict upcoming trends. The quantity of exhibition also introduces specific challenges, not always widely publicized across mainstream platforms. This diversity of location requires our retrieval system to cast a wide net, pulling data from multiple sources to ensure getting enough data. The variation in how these events are advertised also tests the adaptability of our models. So here are all the websites we use. You can see there is 6 websites in total. Like said previously, we took data from a lot of sources to get a maximal amount of data corresponding to our subject and being in the defined time interval. For collecting data, we use different methods, HTTP requests in Python using the Python library, as well as Beautiful Soup to fetch web pages and parse the HTML. Request to the website API to get directly the JSON without having to parse the HTML, and data processing to remove unwanted characters by replacing Unicode with ASCII equivalents. On every website, our query were about So now I will talk about Boolean and vector space model. The Boolean retrieval model is based on Boolean logic and classical set theory, where documents are represented as set of terms. Queries are formulated using Boolean operators such as and, or, and not, which links such terms together. In this model, a document is retrieved if it satisfies the Boolean expressions specified in the query. This means that the document must contain or not contain the exact terms as dictated by the Boolean operators used in the query. The primary advantage of the Boolean retrieval model is its simplicity and the precise control it offers over the retrieval process. However, it lacks the ability to rank results based on relevance, as it treats all matches as equally relevant. The vector space model is a more sophisticated approach to information retrieval. In this model, both documents and queries are represented as vectors. The weight in the document vectors typically reflects the important techniques like TF-IDF or tail frequency inverse document frequency. Similarly, query vectors are constructed using weight that signifies the importance of each term in the query. This model allows for ranking documents on a scale of relevance, which provide a more nuanced retrieval performance compared to the Boolean retrieval model. So here we can see the result of our Boolean model. We have the possibility to put words, like for example, vehicles and electric, and put like operators between words. So the first, the second line we can see are documents who have the word vehicle but not the word electric, and the second one who have both words. So like I said, here we have a list of documents having the vehicle not electric and document with the vehicle and electric. We can remember some documents like 46505 or 46513. Find them, because this time we're looking for electric vehicle and we have the relevant score. So here again, we can find them. Okay, I will now talk about the different metrics in our evaluation model. So first, the precision measures the accuracy of the retrieved documents, indicating the percentage of the results that are relevant to the query. In the context of detecting social events in Korea, high precision ensures that most retrieved documents are pertinent, reducing irrelevant information. Recall evaluates the completeness of the retrieval, reflecting the proportion of all relevant documents that were successfully retrieved, crucial for not missing any significant events. We also compute the F measure, combine precision and recall into a single metric by taking the harmonic mean. It helps assess the retrieval system overall effectiveness, ensuring an optimal balance between fetching relevant information and maintaining relevance in the retrieved results. MAP, or arranging the precision score at the ranks where relevant documents are found. It's important for evaluating how well the system ranks the relevant documents, with a high MAP score indicating effective prioritization and presentation of the most pertinent documents first. Finally, we also compute the temporal relevance, which measures the percentage of documents and the percentage of relevant documents within a specified time frame compared to the overall set and to the relevant set of retrieved documents. This metric is key for detecting social events, as it ensures the system prioritizes recent and timely information crucial for accurate and prompt analysis. Okay, about our evaluation model. So first, the evaluation model uses a vector space model in order to assign each document a reference value. The value is calculated through cosine similarity, ensuring that strong relevant document can be easily determined. This threshold ensure the document meeting the minimum relevance and documents who can't be identified. Finally, the system computes the various metrics such as precision, recall, F measure, mean average precision, and the temporal relevance. So here we can see that exhibition, which is our main topic, has this query at 100% precision, which makes sense since we took our documents according to the fact that they will be about exhibition. When we try to go for more specific topic like museum, we lose in precision, and because there are very few documents about chocolate in the dataset, so even when all relevant documents are retrieved, indicated by the recall of 1.0, they represent a really small fraction of the total number of documents retrieved. Finally, the temporal relevance shows us here that 25% of all documents are in the set interval of time. When we look into the relevant documents of each query, we can see that 9% of exhibition documents are actually in the specific time, and that there is less documents of other. Thank you for listening.
Hi, this is team 13, and we will start our presentation. Our contents will be like this, and first of all, we will talk about the definition of social events. And the meaning of the social event we define is the events that shape social interactions and perception, influencing the behavior of individuals and groups. And at this point, 22nd National Assembly election in Korea might be the fitting event. Therefore, our scope of social event was reduced to the National Assembly election. The purpose of our system is to provide users with information on articles related to the National Assembly election by putting them in order of relevance to search terms. First of all, we crawled news data from 동아일보, politics category article from January 11th to April 10th by using a beautiful zip library. Over 7,000 articles were crawled initially, and to ensure a clean data retrieval, approximately 3,000 duplicated articles were eliminated, resulting in 4,652 independent articles stored in a database for a model utilization. And since we don't have a Korean stopwords module, we customized the list as you can see in the presentation. And we tokenized the data using Cormoran library. Also, we use scikit-learn k-means clustering modules to store a keywords of the article. These keywords, since our programs are showing only title in initial post search page. Also, we crawled the evaluation data using Selenium, which is a data from a keyword search page of 동아일보. I'll tell you about our model design. The search model we utilize in our IR system consists of the Boolean model and a vector space model. First of all, Boolean model employs an inverted index to efficiently retrieve documents matching user queries, iterating through documents to tokenize and build an index. When processing queries, it intersects documents ID for each query terms to find matches. To improve usability, the system integrates publication dates, enabling users to access relevant articles in most recent order, enhancing the relevance and practicality of retrieved information. And we also implemented vector space model by using vector representation, maintaining consistency between training and query data while reducing dimensionality and noise. The query preprocessing pipeline focuses on retraining user-provided keywords, enhancing retrieval accuracy by aligning queries with processed article datasets. In the class definition, TF-IDF factorization and cosine similarity enables efficient document retrieval based on semantic similarity to the queries. To manage output overload, a similarity threshold of 0.12 filters relevant articles, aligning with evaluation metrics for optimal precision, recall, and F1 score. This refines output mechanism improves usability by presenting user with more focused and relevant information. Also, we use Python GUI library for the user interface.
Oh, can you see my screen? Yeah. So now let's proceed to a live demonstration of our system. For our user interface, I utilize tkinter. So there are two buttons here. First one is to select our models, and second one is about us. Oops. Oh, sorry. I think I can share several screens. I want to show all of our windows of our IR system, but I think I cannot do that. Sorry. Then I will share our UI screenshots. So this is our actual UI system. And when you click the start button, you can choose two options here. First one is Boolean models and second one is vector model. And when you put some queries in here, like in this box, you can see the old results of about our queries. And when you click this title, you can see the original articles in this window. And the main functionality is social. You can see the graphs here, and this functionality enables users to visually assess which social events were significant during those periods and detect or evaluate social events. And we can directly observe increasing in this period, especially as election day approaches. And let's move on to our slides again. Yes, and moving on to the evaluation phase, the ground truths were collected from actual search results for a few election-related keywords from 동아일보. We employed precision, recall, and F1 score as usual to assess the model's performance, and I also calculated the average those scores. As you can see here, Boolean model exhibits Sorry. I apologize. And now you can you see? Okay, sorry. As you can see here, Boolean model exhibits higher precision but lower recall, and vector model displays varying precision and recall trade-offs. And additionally, I created two custom metrics by myself. Time relevant score evaluates article recency, providing insights into the timelines of our predictions. It assigns a score of 1 to just a few articles, like top 10 articles within a user-defined recent time frame, like 10 days. Cosine similarity without considering time, I gave more weight of 0.9 to the F1 score in our evaluation combined metric. It blends the F1 score and time relevance score using weighted averages to evaluate overall performance, considering both relevance and recency. So although we didn't have a chance to implement time relevance in the vector model due to our small team size, I've already prepared actually a formula to factor in time relevance for future updates. So next time around, I can smoothly integrate this aspect into our model and see how it enhances performance. And this is end of our presentation, and I apologize again, and thank you for listening.
Can you see my screen? So, hello everyone, we are team 13, Alexandre, Jérémy, Joël, and me, Tony, and this is your presentation for information retrieval project. So, the aim of this project is to create a query system that allow us to search about social events in Korea using information retrieval techniques. We choose the theme of protest in Korea. For this project, we first had to get a large dataset from various sources. We chose to use public APIs, but also scraping to obtain all the information we needed. To do so, we found an API called News API that allows us for a single request to go and search for all the related articles from approximately 150,000 sources on the web. And we choose to retrieve under. After using this API, we use the Python library newspaper 3K to do some scrapping. Before implementing our query systems, we had to index all our articles. So we created an inverted index matrix with each word associated to the document it is present in. So in this example, lead is in document 1, 5, 6, etc. It was then finally possible to implement our query system. So we started with the Boolean query because it was the easiest one with the keywords and, or, and not. So in this example, you can see doctor and law are present in document 1, 8, 17, and 24. Finally, we implemented a vector space model using TF and TF-ADF. The program processes and evaluate the distance between those two words. To evaluate our system, we choose some articles that are relevant about the protest in South Korea, and then we use our system with queries. So we compare the results of our queries with your own best articles that are relevant. We test our results on 3 different levels with the first tier of values, the second tiers of values, and then we use all the results. And we calculate the precision and the recall for each request and each level. And finally, we also calculate the average precision and the median recall. So as a result, finally, we could try to reach our goal, which was to detect social events in Korea. We asked our system to look for articles about protests in Korea. We are quite satisfied with the results as your system got us several articles about recent week legislative elections, and this was a major topic here in the last 2 weeks. The second topic retrieved was about disputes in land property between South Korea and Japan. We were glad to get this result because this was something we didn't hear about, but our algorithm was able to detect it and made us discover this news. And finally, our system also retrieved articles about South Korea, but more related to another country such as Russia. This shows that we have to get really precise in our query depending on how wide we want the radius to be. In some case, getting this kind of articles could be interesting, but if the user wants to know more about what's happening in Korea, maybe it will be unrelated. Thank you for your attention.
Hello, can you hear me properly? Okay, I'm going to start my presentation about the project, information retrieval systems, like everyone else. Here's a brief index of what I'm going to talk about. I'm going to talk about my data, the Boolean system, the retrieval system, and the performance. First, let's start with the data. Where did I collect the data from? I collected the data from the Korea Herald and the Korea Times. These are two online English newspaper about Korean news, and they provide information and analysis aimed at an international audience. Then, where was data collected? How was data collected? For seeing this, for explaining this, I'm going to go one moment into Google. I used a scraper and a scroller, one from the Korea Herald and one from the Korea Times. In my code, you have to pass the URL, but not the main URL. It goes by sections. So you go to one section, for example, life and culture, and you pass this URL. Then here there are all the main news related to this section. If we inspect the elements, we can see they all have the same class, news text, and the same tag. This one will have the same. And thanks to a beautiful soup, a library in Python, I can access this HTML and get all the news that have the same properties. Then after that, I simply access the attribute href and simply access each news article. For retrieving the information about the text and the title, it's basically the same. I inspected the document to see the class and the tag. We see it's div and text box, and simply here we have the text. And like this, we retrieve it. For the crawler part, for going, because after you retrieved all the news from one page, you have to go to a second page, right? If you see here, it works like an index. So basically, my code it modifies the URL for going to the next page, and it stops at the date you give my code. You say to my code. Then moving on. All this data it's stored in a text file. Here's my data set. It consists of the title of the news, the text of the news, the date. It's separated by equal signs for reading the text later. How much data did I use? For my precision and recall analysis, I used 950 documents or news in total. because I have to know from a single topic that I was retrieving how many documents there were in total in my data set in that topic. Then for seeing the performance, which I will talk about later, I used up to 4,600 documents. Let's start now with the Boolean system. I'm gonna skip the code. I'm not gonna explain the code because otherwise I will have no time, and I wanna skip directly to the results. The results, it's the Boolean system simply works. If you input a word such as MLB, in this case, I used a smaller data set just to show the results. It retrieves all documents that contain the word. It will retrieve all the documents that have MLB and not Giants. Here another example, MLB or golf. It retrieves the combination of all documents that have the MLB word in them or the golf word. The precision will vary depending on the complexity of your query. The more precise you are with your query, the more precision you're going to have. Now, moving on to the vectorial system. Once again, I'm going to skip the code part. If not, I'm sorry, but I'm not going to have time at all. I'm in the vectorial system. I use two topics that are they've been very talked about lately in Korea. One is the medical situation with doctors, and the other one is elections. So let's start with the medical topic. For a medical topic, and out of my 950 documents, I had in total 57 that talked about this. I used the query doctors met medical students documents. Until I retrieved all the total documents about this topic, 75 were retrieved in total. So when k equals m, being n the number of objective documents, the precision was 76%. From all case, from 1 to n, this is the lowest precision of all case. This makes sense because the more documents you retrieve, the less documents there's about it, and probably the less weight they have. We can say that the best k in this case is 48. This means that after retrieving 48 documents, I had the maximum precision with a reasonable k value. This precision was of 95.83%, having 46 true positives and 2 false positives. 66 documents. 66 documents were retrieved in total after having retrieved all the documents related to this. As before and as expected, the precision curve starts high and starts losing precision when k gets big. This is very logic because the more retrieved documents about the topic, the less documents about the topic there are in the rest of them. In spite of that, a good precision was accomplished, starting with 100% precision for the first 17 retrieved documents, going down gradually until ending up with 74.24% precision after having retrieved all the 49 documents about the topic. The best was after retrieving 38 documents in total, so k equals 38. Where I had, after retrieving 38 documents, I had a 95% precision. Recall and precision curve about this topic. Nothing much to say here. It's the same conclusion and analysis as before. Balanced data set and I'm retrieving more proportionally the good amount of true. So a brief conclusion, my code works fine and is consistent when having a balanced data set. This means that the data set has a good amount of documents about the topic for better weight calculations. If I was searching a document or a topic that only had one document out of the 950 documents, it's not going to work as well. Now, performance and time complexity. I also wanted to check performance, see how well optimized was my code, since it works in a linear fashion, and I'm not using any parallel programming techniques. And a good information retrieval system for the user has to give good results and in the smallest amount of time possible. So for doing this, for seeing how time complexity increased with total document count, I retrieved more documents, the maximum being 4,689 documents from both newspapers, with all the news from yesterday, 19th of April, until the 28th of April included. I am going to divide this into two sections. Pre-processing time. This means calculate. This is the time after the user makes the query. How much time does the system take to retrieve all the documents. For retrieval time, after the user makes the query, it's really small. It's little time. For 950 documents, we have 0.003 seconds, and for 4,600 documents, we have 0.01 seconds. I don't even make a graph because it's such a small time, and this is good because this means we're not making the user wait. For code scalability, so the pre-processing time, we can see it grows kind of in an exponential way. With 950 documents, it takes roughly 4 seconds. It's 3.8 seconds of pre-processing, and for 4,689 documents, it takes 91 seconds. We can observe easily how it increases exponentially as number of complex operations. These operations need more memory and processing power, and for average computers like mine, it may take more time, which is the case. Conclusion about this: even though time complexity increases exponentially, it retrieves a good amount of documents in a reasonable time. And I am doing this on my laptop. I didn't do it because it was not convenient for my test, but there's an easy solution for this. We can solve easily this problem, but once the user makes a query, he can do a query again. So the only waiting time will be the pre-processing time. And we've seen here that the retrieval time is so small that we wouldn't make the user wait. This is my presentation. Thank you for listening.
Hey everyone, I'm sharing my screen now. Okay, so here we go. So that's homework for the information retrieval evaluation on social event detection. So in my case, I decided to take the subject South Korea's intelligence action concerning North Korea to see what are the actions of the data gathering and everything about that acted by South Korea towards North Korea. So the tool I decided to use are Selenium to scrap source information. I used Node.js to use Selenium also to evaluate the information that I got. To evaluate it, I use regular expressions to check the words that were available, their position and all of that information. So the source information that I used is called Le Figaro. It's a French newspaper. I collected information from February 2022 to the 8th of February and 45 articles from it. So as far as the result that I got a pretty good precision of 66% with a record of 400%, but the real issue that I got was a match rate. I only had 3 match, and one of them was a false positive. So only had 2 true positive matches from my research. Relevancy was pretty good if you remove the false positive that's right here. We have like 3 or 4 days of difference between the 2 articles that were published on March 2024. So pretty good time relevance there. As far as the brand that I had, Selenium was not easy to use because I was scraping a website, so you have the issue of being banned. I've needed to go slowly to get all the information that you want, properly scraping the website, getting the proper information, avoiding taking information that is useless, making sure that you have the word issue that I had was a match rate. That was a really big issue because I couldn't do a lot of research with only 2 articles on my subject. So that was not great for my homework. As far as the conclusion go, if I needed to do that again, I would like to use more sources of information, not only the Figaro, but others. Like News API maybe could be used boon for the number of matches. I have an overall search duration. I searched for more than 2 years and couldn't find more information because it seems to be a really current subject, really contemporary one. And I would need to probably use less time for the research and more sources. and maybe a different way to get information, because Selenium was pretty unready to use. It wasn't really good, so maybe another way would make my life easier, and the do you have any question?
All right, so we are group 16, and my name is Ahmed, and today I will be presenting our project for the IR evaluation and social event detection. So I'm gonna briefly talk about the objective, the definition, the topic and sources we choose, and then I'm going to talk about our different development process and parts, and finally talk about our results and conclusion. So the objectives, as all the other groups mentioned, we had to collect data from news and to and see our results. So first we had to define what's exactly a social event. So for us, the social event was about like political rallies and cultural shifts that shape public discourse and social trends. And for us, we decided to focus on the Korean legislative election. So this was our topic, the Korean legislative election of 2024. And also, like a lot of other groups, we decided to use the News API that had many internal sources and renowned news outlets. So let's dive on our development process. So first we gathered data. So as I said, we used News API, and we were able to gather 500 articles about Korea. One thing that retrieve data from the last month. So this helped us to already have one step ahead for the time relevance. But after that we've gathered these 500 articles, we had to format them and index them and pre-process them, because we only had access to the title, a description, and only a few words from its whole content. So we mixed all the content, title, and description, tokenized and indexed the articles to make sure that we would be able to use them for our models. Then step 3 was the implementation of the models. So nothing really fancy here, just implementing what we've learned in class, and with the help from the internet and some of ChatGPT, where we were able to implement it. Our results and to see how well it was working. So we dove in the articles to find which one were relevant for our topic, and made an array of ideas of the article that were relevant, and also implemented like the basic math functions to get our results. So these are our results. So as you can see, our Boolean model worked pretty well. Our vector space model had a little bit more of trouble, and as of time relevance, we didn't have any problem for both of them. So we quickly wrote like which one were better for us. So like the strengths of our Boolean model was, it was very simple and very precise, and yes, for our query, it worked very well. And for the vector space model, best thing that was that it provided a ranking of all the documents, but it was very sensitive, and it had a weakness, because in our case, the News API didn't give us all the content of the articles. So maybe the vector space model didn't show its full potential, even though it worked okay. Could have maybe worked better if we had more more words or more content for each article to get to be even more precise. So in conclusion, it was a very interesting project to apply all the theoretical knowledge and to have a concrete use of the Boolean model and vector space model. And also we saw the importance of data in achieving desired results and how much our data should be as polished. We were able to enhance our understanding of the information retrieval overall. Thank you for listening. Do you have any questions? Okay.
Hello, do you hear me? Je vois pas mon micro s'allume. Yes, okay. So share my screen. Okay. So I will present you my project on information retrieval. The goal of this project was to detect events in Korea like party, festival, etc. Here you have the bunch of keywords I use like community event, performance, concert, social gathering, etc. So to do so, I use a Reddit API focusing on the subreddit Korea. For the time of this to get the data, I get the data from 1 of January of this year to the time where you launch the script. So if I launch the script today, I will get information till today. But I was limited by Reddit API free access. So I only had access to 1,000 each of articles, which means that I get articles only to like mid of February of this year. As result, so my script for both Boolean and vector space model viewed 872 articles the time I launched the script. For the Boolean model, I retrieved 32 relevant articles. I store the data like this with the title, the link, and the date of the article. When you have the link here, for example, I don't have a link with Reddit, but is a link of Korea Times. It's when people are posting directly and only a link in the Reddit post. It redirects directly to this link and not to the link of the Reddit post. Then for evaluation, here my recall is not good. I use wrong equation for it, so I can take it into account. I realized it too late. And for precision, for Boolean model, I get 10% of precision, and for and for temporal relevance, I get 75% and 4% for vector space model. That's the end of my presentation. Thank you for your attention. If you have any question. I think so, yeah. Except the fact that Reddit API is very limited, I got not any problem. With Pro either. Pro is a good library, a good package. It's really easy to use and very. No problem, thank you.
Hi. I am Pakwanu, and yes, I start. I collected news articles related to the Korean election using the news API. When I used the search term Korea election, I confirmed that 91 articles containing articles on various aspects related predictions and results, as well as articles with unrelated content were mixed in an appropriate ratio. I decided to use these articles as a sample because I felt that these articles were suitable for quantitative analysis and that the ratio of relevant and irrelevant articles was appropriate. After deciding on the sample, I personally read each sample to identify relevant articles and determined that a total of 31 articles contained content related to the Korean election, which was the preset for. And because I considered time relevance during this process, the articles I judged to be suitable all satisfied the time evaluation criterion when evaluating the model later. Instead, I created several models and checked the changes in precision and recall. The Boolean model utilized exclusion keywords to filter news articles and extract relevant ones. The first Boolean model excluded articles containing the word north in the body, while the second model excluded articles containing frequently occurring unrelated keywords such as North, Samsung, Microsoft, and China. Using these models, 72 and 61 articles were respectively retrieved from those.
잘 안 들려요. 크게 해주세요.
네, 알겠습니다. The vector space model calculated consign similarity between TF-IDF vectors of news 다시 할게요. The vector space model calculated cosine similarity between TF-IDF vectors of news articles to extract related ones. TF-IDF vectors were computed using the TF-IDF vectorizer from the scikit-learn library, and cosine similarity was calculated using the cosine similarity function. At first, the process of removing stubwords was coded using a related library, but after learning that TF-IDF vectorizer performs such processing, I deleted them. The standard for calculating cosine similarity was to set the first article, South Korea's opposition wins in landslide parliamentary elections, as the standard for the article I wanted to find, and calculate the cosine similarity of all articles with the first article. By setting the cosine similarity threshold to 0.05, 0.07, and 0.1, three vector space models were created, resulting in 50, 29, and 16 articles retrieved respectively. And when I came up with the evaluation results, I did not capture them. Instead, I captured them when I made the presentation. Change, so the results changed. So I will tell you the results based on when I wrote the code. Precision and recall were used to evaluate the performance of each model. Precision increased from approximately 0.43 to 0.49 when additional exclusion keywords were used in the Boolean model, while recall decreased from 1 to approximately 0.96. Through this, we can see that as the number of negative words increases, precision increases, but recall decreases, since the negative words were not used in almost all relevant articles. The recall value is close to 1. In the vector space model, increasing the cosine similarity threshold led to an increase in precision and a decrease in recall, like this capture. 네, 끝났습니다.
Sorry, could you hear me well? Yes. Could you hear me? Okay, thank you. So I'm gonna share with you guys what all I did in the homework 1 of our course, the natural language processing and information retrieval. So for the project 1, the objective of the project is detect the social events in Korea and analyze the effectiveness of two information retrieval techniques, which is the vector space model and the poly model. And the social events that I choose is the e-sport events in Korea. And after you two techniques that after you the two information retrieval techniques, we will evaluate the precision, recall, and temporal relevance of each retrieval approach for the different queries. So let me talk about the methodology. News API, API to collect news article in Korean language related to the esports events, and the time range for the data collection was from March 20 to April 15. And we have 3 queries related to the esports events. The first one is the LCK. This is the short term of the League of Legends Champions Korean tournament. And for the query 2 and 3, this is the more two well-known esports team name, that which is Team One and Genji. And as I said before, the objective of this project is analyze the effectiveness of two information retrieval technique. So we will use the vector space model. In the vector space models, we will use the TF-IDF vectorization and cosine similarity for document retrieval. And in the poly model, we will perform the structure match. So let me show you the result and analysis. Firstly, I will show you the similarity scores and relevant documents for each query. For the query 1, in the VSM similarity score, you can see that there is only one document in the at the indexes that have no similarity score to the term LCK. And for the poly model, we use the not operation. That means any document that have no LCK term will not be counted in the relevant document. So we have like 9 documents that's irrelevant to the query 1. And we do the same for the query 2 and 3, so that we have the result in the query two, the VSM similarity score chart have and the relevant document also have two in the Boolean model. And in the query three, the VS similarity scores is 5, and the relevant document is also 5. Next, I will show you the recall and precision comparison. This graph is a recall and precision comparison between VSM and poly model. Look at the graph, you can see that in the query one, VSM and poly model achieve high recall, with the poly model achieving perfect recall. However, the VSM has lower precision compared to the poly model, and the retry documents were temporarily relevant, falling within the specified date range. And for the query two, the polling model outperformed VSM with perfect recall and precision, while VSM failed to retrieve any maintained temporal relevance in the retrieved documents. And in the query three, both VSM and polling model achieved perfect recall and precision. The retrieved documents was also temporarily relevant. And in conclusion, the analysis demonstrates the effectiveness of both VSM and polling model in retrieving news articles related to sports events. Why we see the polling model generally show the higher precision, the VSM approach provided satisfactory results in terms of recall and temporal relevance. So that's it. Thank you for your listening. I have like 20 docs have been collected, but there are just only 11 documents that related to the esports events in Korea. Yeah, I think it's a small data set because the time range that I said is too small. Thank you.